Introduce Dr. Ian Halliday to you. Ian's the CEO of 3T RPD, who is an independent service bureau offering additive manufacturing components for customers.
Thank you very much, David. So I wanted to just start by asking you a few questions to get a feel for your involvement and interest in additive manufacturing. So firstly, if you wouldn't mind just, if you're actually already using additive manufacturing, either in terms of rapid prototyping or production, if you could see, so 7 to 3, 10, thank you. These questions get harder as we go down. So hope you're up for the challenge. Are you actually interested in using it for production purposes now or in the future? Okay, it's about the same number, in fact. Interesting, thank you. Do you have an AM strategy in your company? Yeah, so that's about half of that group, thank you. And then so finally then, are you actually already using it for production? Yeah, okay, great, thank you very much. Okay, so in terms of what we're going to be talking about, I'll first explain what I mean by additive manufacturing production. It's perhaps a little bit less straightforward than other definitions for production because of the adaptability of the process. So I'm not talking about rapid prototyping. So rapid prototyping in this case is where you just have a one-off product just to test it out either physically or visually or otherwise. So the production isn't rapid prototyping. It's for an end-use component, so it can be anything from a handful of roll hoops for a Formula 1 car. For the Formula 1 team, that's production. Or it might be 100 or even up to 500,000 or 1 million components for an aerospace or an automotive business. The production component will require rigorous new product introduction, so stage gate type process. Probably have part numbering so you can track the parts. Definitely advanced quality systems are required, and as John was alluding to, this is a major challenge in the use of additive manufacturing. And it isn't just about aerospace, it isn't just about metal parts, it's also the consumer industry. So a massive volume of consumer parts. So Materialise, for example, is one of the global main players for consumer parts production. They also happen to be medical production and a range of other things. But consumer and industrial really can be done pretty much with the same equipment. So if you're reasonably new to additive manufacturing, you probably want to know, well, I've seen it used for prototyping, the bits are brittle, you may have had some bad experiences. So is it really realistic? Well, this is one component that you may well, in the future, maybe not too far off, be flying in an aircraft that has this part in the jet engine. So this is GE Aero have this part inside. It's a fuel injector nozzle for one of their jet engines. I wish I had a load of really loud music that we could fight back. Next one, somewhat more consumer orientated, is Nike. So they're actually using SLS parts or polymer parts for the soles of their shoes, and this allows them to be very, very adaptable to the requirements of the customer. I've got a part here I can hand around. This one is the Airbus. It's a bracket it's a TMTC bracket, and this is being fitted or is on satellites. It's for communication systems holding them in place. So this is a space component, aluminium. Richard's labelled it up thoroughly with our name on it, so if you do run off with it, we'll know, at least everybody else will know where it came from. So this is a serious aluminium bracket designed, and as John was saying, this has used a lot of optimization to produce the lightest bracket for the greatest stiffness, and it's considerably stiffer than fabricated brackets. If you want to find out more about that, you can look on BAE Systems, and if you type in BAE Systems TMTC bracket, you'll get the case study and you'll be able to read about it directly. It also goes down to tiny things, so I'd like to have been able to show you a picture of a full jet engine. This somewhat diminutive part is nonetheless very important. It's a little breather tube as a Rolls-Royce case study. So if you're interested in additive manufacturing, how do you know whether it's actually going to be any good for you? And there were some comments on this earlier. Firstly, I would say if you've got anything that accelerates, that's a great starting point. So if it's in a car, in any kind of vehicle, then it's going to accelerate at some time in its life. And if you can make it lighter, you save fuel, you can perhaps make it a lighter vehicle overall. So mass reduction is probably one of the key benefits that you can get. So look for accelerating parts. Of course, if you've got an accelerating part in an engine that's in an accelerating vehicle, even better. Complex geometries, multiple assemblies. So you can cast some very, very intricate objects, but there are limits to what you can do with casting. So additive manufacturing can take you on to another level again. And in this case, you might have, say, an assembly of 6 or so parts. You can build them in one piece, more reliable, lower mass, and so on. And we've got some excellent case studies of that type of application where we've reduced the mass and the complexity of components considerably. Holes and channels. Actually, Additive's very, very good at holes and channels. If you want perfectly straight, smooth holes and channels, then perhaps not. You have to know when to use the technology and when not. But holes and channels, complex structures, all go together very nicely. So you can get performance improvement from that, and long lead times. We've got some fantastic case studies where industrial components, we've reduced the lead time down to about a quarter using additive manufacturing. Now, the point here is not that this additive manufacturing can do everything, absolutely not. The key thing is to know when to use it and when to use other technologies. It's just one more tool in the toolbox. So, in terms of the growth of additive manufacturing, here's some numbers that have been plucked out of the Wohler's report. And the 3 different measures, they all show pretty much the same thing. So the number of machines, this is metal machines, in revenue from service providers, and in two different aspects. So the market at the moment is growing around about 30% a year. Now, different parts of the market are growing at different speeds, so I'll come on to that in a moment. Just to show that this data is real, this is taken from a presentation made in 2014 by GE Aero, and the blue line illustrates the applications that they're using the additive manufacturing technology for. I think it's fair to say GE are probably 3+ years ahead of pretty much any other large industrial manufacturer in terms of their use for the technology in more safety critical applications. Truly impressive. So, one of the things about GE is they're right at they're kind of well through their development stages. So but most customers will go through the same stages, just at different speeds. And I've got a couple of timelines I'll show you for that. So the first stage is really, we're interested. So perhaps half of you here are interested in seeing whether additive manufacturing might be useful for you. Now that stage can last maybe 10 years, depends on your industry. Certainly quite important. You'll probably start to use it for rapid prototyping work, and see the little green line at the bottom, so the AM value, or the additive manufacturing value, is starting to creep up. In the second stage, then you're beginning to apply the technology. There'll be if you think back to the GE line, then they've got perhaps 2 or 3 components they're putting through production. Next stage, once you've got your you might have actually started having an in-house team, and incidentally, having an in-house team for even a small company, even if it's just one person, dedicated to additive manufacturing is a very, very important step. So the team that John has at BAE Systems of 25 or more people is a really powerful capability. Then moving into stage 3, you're starting to use it for serious production parts, and you may even have production parts that are committed to additive manufacturing. They can't be made any other way. And then stage 4, and I put GE as an example here. They've got facility with potentially hundreds of machines in it, 100 or more machines in it. So they are way ahead. Timeline-wise, this is pretty busy timelines. But you can see over on the right-hand side. So you can see the timelines. So for GE and Airbus, this is the only data I had available. You can see that they started a long time ago getting interested in additive manufacturing, and I think you'll find a similar sort of timeline for BAE. I'm going to leave the microphone, just point at a couple of things here. So see with GE in particular, what they've done is they've actually committed to production engines back in 2010. They acquired the world's largest metal additive manufacturer here, and that has leveraged the rest of their development very, very powerfully. So the lesson here is Morris, so Morris Technology were at the time the world leader in metal additive manufacturing application, working directly for GE. They've gone on to do some very impressive stuff, and as I mentioned earlier, they've now got a number of real applications up in aircraft. To give you a sort of slightly different view, if you're in a different market, so if you don't have safety critical parts, the timeline can be a lot shorter. So in the case of Nike, they didn't really get stuck into looking at additive manufacturing, so far as we know, until about 2009, and yet only 3 years later they were talking about launching products, and this one. So in 2012 they actually launched a shoe using additive manufacturing. So you can compress the cycle if you go about it the right way, and probably nobody's going to die if the shoe fails. So not having a safety critical product is a big help. Just a couple of quick points here. So where are we in the development of the market? Well, we're still very early on in the development, but the market itself is not a single thing. It's made up of a lot of different markets. So if you're now thinking about additive manufacturing, you need to find a supplier. So what are you going to do about your dealing with the supply chain? One of the challenges right now is that there aren't very many competent additive manufacturing suppliers available to you. You might then consider to set up your own vertically integrated in-house capacity. These two little slides just show the rate of growth, but the question is that sort of rate of growth? So if you go from 5 billion now to 75 billion in 2026, one of the questions if you start depending on additive manufacturing is, will the existing supply chain be able to grow at that speed? So we tend to just focus on the build part of the process. We see the technology passed around the bracket there. We've got another interesting sample here, which is just a bit of chainmail all built in one piece. So if you want to see that, come and grab that off me later. But the focus is about the technology, but that's not really the whole picture. The whole picture for a supplier is the complexity of all of the things that have got to go around it. And again, John alluded to that earlier. We're talking about a complete process chain, which includes, well, all of that stuff. So I'll move on. So what can you do? Well, firstly, going back to those early points about, is the technology applicable to you? You've got to decide whether it's right for your company. There are plenty of companies where they have no application whatsoever. And that's just as good a decision as trying as actually going for it. Don't forget that it's a whole system. It's not just about the supplier whole system. So my previous rather complex diagram, there's all those things you've got to put in place to make the build process work properly and control it. And we've still got a long way to go. The same applies inside a company. We've got one excellent customer where their design release process has caused an absolute nightmare for putting additive manufacturing into the company. So it's a relatively easy thing to overlook. So there's a lot of things you've got to consider in taking it on board. So developing a strategy is very important. You could consider setting up an in-house team. I'd recommend at least identifying somebody to do that job. So somebody who's the champion for it and who understands the technology. Secure your supply chain. Most OEMs require more than one supplier. You may be the first supplier, who you can choose for your second supplier. And there's going to be a lot of competition for the supply chain volume and capacity. So don't underestimate the challenges. It's a lot more than just saying, well, this is a great technology, isn't it? And equally, don't overestimate what the technology can do for you. It's easy to get very excited about it. When you see things like this, you think, oh, how on earth did you make that? That's leading you in the wrong direction. So overestimating the benefits from additive is probably more dangerous than underestimating. It is just another technology. So that's the end of my presentation. So thank you very much.